Today I'm going to do a lecture on Unit 6. I'm going to call this lecture Router on a Stick. I'm going to do Lab 6.3.3.7 in Packet Tracer, and then while we're doing the lab, I'm going to talk about some different concepts that are presented in the chapter and how they relate to the configuration on the router and the switches. Okay, if you look on the top of page 3 on your lab, you can see these are what we need to set the lab up in Packet Tracer. A Cisco 1941, a couple switches, and a couple computers. And so basically, I'm going to go down here and start with adding one Cisco 1941 router. Then down here, I'm going to click on the switch icon. I'm going to hit Control on my keyboard. That activates the switch icon there. And now I can just rapid fire as many switches up there as I want. Same thing with the computers. I'm going to hold down Control, and then I can rapid fire as many PCs as I need onto the workspace. And then we need to cable the devices. So then if you look at page 1, it shows you that we have a loopback address up there, which we'll worry about later. We have gigabyte interface 01 goes to fast Ethernet 05 on switch 1, so that's the link between the router and the first switch. The two switches are linked together by using port 1 on both switches, and then computer A goes into port 6 and computer B goes into port 18 on the second switch. So again, if I go down here to my copper straight through cable, hold down the control key, now I can rapid fire connecting these cables up. So I want to go G01 goes to 05 on the switch, and then on this switch we go from 1 to 01 on that switch, and then on computer A we're going to go from the computer to port 6, and then on the switch we're going to go from 18 to computer B. Then you go down here, just click there or hit the escape key, and it takes you out of that mode. If you want your router to match, you can just simply click the label like this and edit as required. Like that. PCA and PCB. Okay, on the router we are going to configure this physical interface G0/1 with sub interfaces. I actually made a little note there that lists the IP addresses for the sub interfaces. Note that when you first fire up, we always want to say no to this message. We want to configure the router ourselves. And so the first thing you're going to do is go into config T and then into interface G0/1. And to do sub interfaces, basically what we're doing is we're making virtual interfaces. So we're going to make 3 different virtual interfaces out of this one physical router interface. So now we'll be able to run 3 networks or connect 3 networks up to that one physical interface versus having to have 3 separate physical interfaces to do the same job, along with 3 connections to the switch, 3 connections to that switch to do the same thing as just having 1 line per device running between the router and the switches over one single interface. In order to do that, in order to have more than one network go between the router and the switch using only one cable, we have to turn this cable into what's called a trunk. Right now the default is switch port access, which means you can only have one data network going across that cable and the addition of one voice network going across that cable at the same time. That's your limit if it's in switch port access mode. Same with this cable here. We need to turn this cable into a trunk, this connection, and we don't actually do that by changing the cable. The cable is just a physical copper cable. We do that by changing the ports that the cable is plugged into to give us that added functionality so that we can run multiple VLANs over that connection. So to do a sub interface, you're simply going to type in the main physical interface number, then a period, and then the sub interface number that you want to assign to it. This number can be any number between 1 and 255, but you normally want it to be something that makes sense to you. So when we make VLANs, we normally call them like VLAN 10, 20, 30, 40, 50. And then we usually on the switches will give those VLANs a name to represent what their purpose is. And you want that VLAN number on the router to match those VLAN numbers on the switches so that when you're looking at your configurations, everything makes sense to you. So here we're going to go into subinterface G01.1, and you see that it wants the IP address 192.168.1.1. So if we try to do that right now, you're going to find out that you're going to get an error because the router knows that we're making a sub interface. And you'll see that the error is that it's only allowed if it's configured as part of an IEEE 802.10 trunk, basically. So we have to tag these packets using either 802.1q or ISL. ISL is Cisco's proprietary version for trunking and tagging packets, and I've never ever seen it used, and you'll never see it used in this course either. So what we're going to do is we're going to do the command encapsulation, and then if you do a question mark, you'll see you have two choices. Or actually, you only have one choice. Like I say, you're never going to see it use ISL. And so if you just hit D and then tab to complete the command. Oh, and then we have to give it the number. And so right here, we want the VLAN number to be 1 in this case. Now, when we go to add our IP address, it'll let us do it, and there's no issues. So we're going to do the same thing for the other sub interfaces. So the next one we're going to do, and by the way, I'm just using the up and down arrow keys to recall my commands instead of having to type them all over from scratch. And so now I'm going to do the G01.10 right here, and I'm going to do encapsulation DOT1Q10 like that. Then I'm going to change the IP address by just simply changing the 1 to a 10, and all done. And then the same thing for subinterface.20. You do encapsulation number 20. And all this does is it says when anything goes out that interface, those packets are going to be tagged with a DOT1Q identification number of 20. So then when it gets to the switch will be able to recognize that as belonging to VLAN 20 as opposed to VLAN 1 or VLAN 10. And then we're going to change this to a 20.1. And basically I'm almost done. Now I want to exit back one level, and I want to go into interface G01. This is the physical interface now, and the only command you're ever going to issue on the physical interface is the no shutdown command. And now you'll see that all of those sub interfaces have come up. So you don't have to do no shutdown on each individual virtual interface. You only need to do it on the physical interface. I normally do that first, but the lab has you doing it last, so it works either way. Um, so I'm just showing you the way the lab wants you to do it. So now we've basically got our router configured as far as the networking part goes. Okay, now we're going to configure the first switch, and again we're going to go into the command line. If it asks you to enter configuration mode, you'd say no. And the first thing we need to do is port. When we look at our chart, we have port 5 is connected to the router, so we need to turn port 5 into a trunk from switch port and some switch port access to trunk mode. That'll turn this line into a trunk. So we're going to go to config T, we're going to go to interface FA05, and we're going to do switch port mode trunk, and you'll see that it changes from switch port access to trunk mode. On a real router, when you do this, it's going to give you an error saying that the encapsulation needs to be changed, and so you would do switch port trunk encapsulation and change that from auto to trunk. And while I'm in here, I'm going to go ahead and do the interface FA01, because that needs to be switched to trunk mode also. And you'll notice now that the line was green, now it went down because one side is configured for trunking, the other side is still set for switch port access, and it won't work that way. They both have to be using the same encapsulation protocol in order for that link to work. But we'll worry about fixing that on switch 2 a little later. The other thing they wanted done on the switch for now is they want us to create some VLANs on the switch. And so on switch 6 they want a VLAN 10. So we'll go here, we'll go back one level, and we're going to go VLAN 10, and they want it named students. So now you'll notice that the display, the prompt switched from config to config VLAN. So now we're in config VLAN interface. If we do a question mark, these are our options, and the one we want to use is name, and we want it to be called students. So now that VLAN is made. We're also using a VLAN 1, but that's already configured, so you don't need to worry about that. So if we do this, show VLAN, you'll see that there's our default VLAN, VLAN 1, and you'll notice that which ports belong to VLAN 1. Basically all of them. Everything on the switch is automatically assigned to VLAN 1 out of the box. So we want this VLAN 10 to service this computer A, so we need to get port 6 assigned to VLAN 10 versus VLAN 1. So the way you do that is we're going to go back to config T, we're going to go into interface VLAN, or excuse me, interface FA06. And it's a simple command. We're just going to go switch port access VLAN 10, and that's all there is to it. Now if we go back and notice that I typed the word do in front of the command show VLAN, that's because I'm still at config interface mode, and show commands only work at exec privilege mode, so, and in user mode before that. So to get around that, if you put the word do in front of the command, you can run that command at any level in the router. And now you'll notice that VLAN 10 has port 6 on the switch assigned to it. So now the computer will be able to connect to the router over the trunk. The last thing we had to do here, or another thing we had to do here, was configure the computer itself. So PCA is supposed to be on 192.168.10.3, and the default gateway would be your router address, 192.168.10.1. That's fine. So if we close that and check this, we should get, so now that I just pinged the router address, so we have traffic going from the computer up to the router and back. There was one thing left to do on the switch. They wanted the VLAN 1 to have an address on it. And so we'll go back into the switcher. Go back to config T. Now I'm going to go interface VLAN 1 and then IP add, and we're going to do 192.168.1.11, and then he has to get the subnet mask. Okay, we've done that. So now from there I should be able to ping the router interface that's on that network. And it's not working, so we'll have to do a little troubleshooting on that. How about let's try no shutdown on the port. Yeah, that likes that a little better. So it's easy to forget the no shutdown command. So even on the virtual VLAN 1 on the switch, we need to do that. So this computer, would we be able to ping this address on the router? In this case we would, because there's a router involved, and by default all of the directly connected ports on the router will route to each other unless you block that. And so at this point this computer should actually be able to ping that address as well as, and you can see that it does, as well as, so it's actually going to the router, going up sub interface 10.1, and then internally in the router it's being rerouted to 1.1 where the ping is accepted, and then the reply is sent back out 10.1 and goes to PCA. So this side is basically configured and ready to go. And so now we're going to work on this switch. And first thing we're going to do is let's go ahead and create the VLAN. So VLAN 20 we want to create, and we want to give it a name of faculty, and then now we want to go to int VLAN 1, and we want to assign that an IP address of 192.168.1.12 with a class C subnet mask. Then we want to make sure we turn that on. And then we want to go to interface FA01. And again, we want to make sure that that's set to be a trunk. So switch port mode trunk, and it accepted that. And then the next thing we need to do on it is assign port 18, which this computer is connected to. We want to assign that to VLAN 20. So we're going to go to interface FA018. And we're going to switch port access VLAN 20. And that's all we need to do there. Notice that it goes down for a second until it figures out what's happening. While it's doing that, we're going to go configure our IP address on PC2, and so that's supposed to be 192.168.20.3. And again, your default gateway has to be your router's interface IP address. And if we close that, now we should be able to ping our router, which is our default gateway. And if we can't, we will just have to troubleshoot. So it looks like troubleshooting, so 20.3 and 20, okay. And here VLAN 20 is made, so let's do show VLAN and see what we got here. We have a VLAN 20, so that looks okay. Let's double check our addresses on the switch, or on the router I mean. So I'm going to do show IP INTBR. And on gigabyte 1.20 I have 192.168.20.1. So that looks good. Okay, after doing a little troubleshooting, I am now able to ping from this PC to the router and back to the PC. The problem was on switch 1 I had VLAN 10 created, but I did not have VLAN 20 created. So when I tried to send something over VLAN 20, it has to be on both switches, otherwise it's not going to get through there. So in order for switch 1 to pass VLAN 20 traffic over the trunks, VLAN 20 has to exist on switch 1. And so at this point, you can pretty much ping back and forth everywhere. So here now I'm pinging from computer to computer right there. But what's actually happening is when I ping from computer B to computer A, it doesn't go like that. It actually goes up the trunk lines all the way up to the router, gets routed from 20 to subinterface 10, and then it goes back down the trunk and gets to the switch, and then the switch sends it out port 6 because it knows that belongs to VLAN 10, and then it gets to the computer. So hopefully that helps you understand subinterfaces a little better. So the reason to call this router on a stick is because it looks kind of like a lollipop. You have one cable going to the router, even though we have several networks running over that one cable. So that's where the name router on a stick came from. And again, on this trunk line we can have several VLANs running across that. And then one other note, if I have a VLAN 10 and a VLAN 20 all, both on this one switch, and I don't have a router, VLAN, the computer on VLAN 10 will not be able to ping VLAN 20 and vice versa. So in order to go from one virtual network such as VLAN 10 to another virtual network such as VLAN 20, you have to have a router in the loop, because it can't simply just go through the switches. It has to go up to the router, get routed by the router, and then come back down. So hopefully that makes sense. And I'll try and do another lecture on access control lists in the next day or two. Bye bye.